Hello, everyone. I'm Rika, the learning guide for the Electric Processing Center and the Electric Sequence Cafe. Today's learning topics cover the electrical sequence and automatic control of forward and reverse driving of alternating current power motors, depending on the time given. If you understood the motor in the previous time and the reverse operation, you can also easily understand today's learning topics. When it comes to electrical automation, PLC is used. Of course, electrical behavior can be controlled through microcontrollers rather than PLCs. Here we're going to cover the electrical automatic control with PLC. First, we will learn about the general electrical sequence and the automatic control part that performs the same operation through PLC in the back. The screen has an electric control box that we can easily see, and the controls box has an electric wiring breaker and a wire lamp that operates on an overcurrent relay trip. You can also view each start button and stop button. The operation configuration is held for 5 seconds by the internal timer when the start button is pressed. After 5 seconds, the motor starts forward for 10 seconds. Then, the forward drive is completed by internal flicker 2 and the reverse drive is started again for 10 seconds. Please note that the direction of the motor and the GL lamp turns on when the motor is stopped. The RL1 lamp turns on when the motor is in the forward direction, and the RL2 lamp turns on when the motor is in the reverse direction. It's a simple configuration that works in an electrical sequence, but let's look at the electrical sequence drawing, and look at it again. In the electrical sequence drawing, we will first omit the section on the main circuit. You can understand the motor's forward, reverse motion and engagement if you have fully understood the motor's operation in the previous time. The first overcurrent relay is powered by a fuse. At overcurrent trip, turn off ON is repeated for 4 seconds and 2 seconds each given time interval by action on flicker 1. When push button 1 is pressed by the user, the timer is powered up, which is then self-maintained by the timer's working contact A. Also, after a certain period of time of the timer, the flicker 2 is energized by a later contact point of the timer. At this point, the flicker 2 is MC1 10 seconds for each contact, and then MC2 repeats 10 seconds for each contact. Then, the RL1, RL2 lamp turns on and off according to the MC's processor. Of course, the GL lamp is lit for the first time, and the timer is turned off when it is in operation. Note the time and operation of each timer and flicker relay. Now, we're going to connect the electrical sequence that we're given. Understand the electrical sequence portion of the image and take a slow look. The sequence is complete. Now we're going to do a motion test. Move the sequence information to the control box for motion inspection, and set each lamp color, the given timer and the flicker time. Take a good look at each part of the action. Now we're going to deal with the electrical automation part. In order to be electrically automated, PLC sequence must first be engaged. First, look at the PLC input and output contacts on the right side of the screen. The input is push button 1, 2, and the overcurrent relay OCR and MC1 to a contact point below. The outputs are connected to YL, GL, RL1, RL2, and to the outputs of each MC1 and 2 electronic contactors. Now connect with PLC. Electrical connections are made to the PLC only instead of the previously used timer. Flicker 1 and 2. Start the connection. Sequence connection with PLC is complete. Here we need to understand the programming part of a PLC, and you have to program the behavior of the timer and the flicker 1 and 2 that was used in the electrical sequence. First, let's open an editor to create a PLC program to see which program was created. This configuration is similar to the electrical sequence, but programming content may vary for each PLC. This is where the PLC operation is programmed by ladder programming. Open an editor window. In the editor window, browse to the programs that have already been created. If push button 1 is pressed similar to the contents of the electric sequence drawing. The timer TO is operated using internal relay MO. The timer setting time of 5S results in internal relays M1, M2 calls being processed in the time zone given by timer T1, which allows the flicker to be processed, and each M1, M2 turns on the contactors MC1, MC2, and RL1, RL2. Also, when the overcurrent relay OCR trip is made, the YL lamp turns off ON every 2 seconds. The operational configuration here is the same as it was previously operated by electrical sequence relays. Let's simply run this PLC program and test its behavior. Now you're all set up for the electro-automation process. Let's move the PLC program and the connection to the control box to perform a full operational test. Take a good look at each part of the action. Today's lesson is about the configuration that works through an electric relay and what we're dealing with using a PLC. Although they have the same operational configuration, using PLC makes it easy to program for different purposes. And with that programming, we can handle more and more of these different electrical automatic controls. You can see that automatic control through the PLC can create various electrical configurations for the user. I've been Rika, a learning guide for electrical labs and electro sequence cafes. Thank you all for watching, and please subscribe and click the OK button. Please leave other questions in the comments below the cafe or the video. I hope everyone has a good day.